So let's talk about infinite limits. So when we're talking about infinite limits, we can be talking about something like the following function here. Y is equal to 1 over x squared. Now, when it comes to working with limits, it's always best if we have a visual. If we are able to draw it and graph it out, visually, it really just helps us see what the limit actually is. So if we're looking at graphing this function right over here, so the first thing that I would start with is if you set your denominator equal to 0 and solve, which would give us x squared is equal to 0, take the square root of each side, but x is still 0. That tells us that we have a vertical asymptote at 0 here. Now, horizontal asymptotes, if you compare the degree of your numerator to the degree of the denominator, right? We don't have a variable in our numerator, so that's definitely less than our denominator, which also tells us that we have a horizontal asymptote at 0 here. Now, as far as x and y intercepts, to find your y intercepts, you would plug in 0 into the function. But if we plugged in 0 here, again, we get 0 in the denominator, which is undefined. That means we actually don't have any y-intercepts here. We actually don't have any x-intercepts as well. X-intercepts, you would set your numerator equal to 0 and solve, but that's like setting 1 is equal to 0, which gives us nothing. So there are no x-intercepts. So what I would recommend is just plugging in a point on the left, plugging in a point on the right. So like if I plugged in a positive 1 for x, you get 1 over 1. So we'd get a point right over there. If I plug in negative 1 for x, you would still get a 1. So you get negative 1, 1. So this graph actually, if we take this point and we follow the lines of our asymptotes, so we follow the curves there. Again, keep in mind, your graph wants to be near your asymptotes. So it looks something like this. So we can have a visual so that we can then answer the following questions. The limit as x approaches 0 of 1 over x squared. So notice it's just as x approaches 0. It doesn't say approaching 0 from the left, doesn't say approaching 0 from the right. We are approaching 0, which means that we are coming from both directions. So kind of think about just following your graph, right, from left and the right as we get close to this line here of 0. So the closer and closer we get to that line, our graph is shooting up, 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 right? And it's just going to keep going and it's going to keep following that line. So it's going to keep going up, 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 which gives us a positive infinity for that. The closer it gets to 0, the higher and higher it's going to go. And again, it's going to continue shooting upward towards a positive infinity. If we take a look at the limit as x approaches negative infinity, all right, so we're approaching negative infinity, so we're going this direction. The further we get left, this graph is just going to continue to go, go, go. It's going to continue to get closer and hug the y equals 0, our horizontal asymptote here. So the further it goes left, the closer and closer it's going to get to 0. So the limit here would be 0, which would actually also be the limit of 1 over x squared as x approaches positive infinity. The same would be true there, right? The further we go to positive infinity, again, it's just going to get closer and closer to that line, closer and closer to 0. Okay, so let's take a look at another example here. So let's use the graph to find the following. So we're going to find the limit as x approaches 1 of x over x squared minus 1 squared, right? And then the limit as x approaches negative 1 of that same function. So for this problem, they want us to use the graph to help us find the limits. So that means that we want to be able to graph this thing, all right? So if we're graphing this here, so x and y intercepts, in order to find your x-intercepts, you want to set your numerator equal to 0 and solve. Our numerator is just an x. That would give us x is equal to 0. So that does tell us right here at 0, we have an x-intercept. Now, a y-intercept, you would plug in 0 for x and simplify. We would get a 0 up top. Well, and, you know, we would get a 0 up top if we plug in a 0 here. 0 squared is this 0. 0 minus 1 is a negative 1. And negative 1 squared is a 1. So we're left with 0 over 1 or just a 0, which gives us that same point there. Taking a look at asymptotes. Vertical asymptotes, you want to take your denominator, set that equal to 0 and solve. So we would take that quantity, that x squared minus 1 squared, set that equal to 0. Take the square root of each side to give us x squared minus 1 is equal to 0. Add that 1 to the other side, giving us x squared is equal to 1. Taking the square root of each side gives us that x is equal to plus or minus 1. Those represent our vertical asymptotes. So at a -1 and a +1, we have vertical asymptotes that we can add to our graph. Taking a look at horizontal asymptotes. Horizontal asymptotes, you compare the degree of your numerator to the degree of your denominator. The degree of our numerator is a 1, that is x to the first power. The degree of our denominator is a 4. This is x squared, but keep in mind that that is being squared, so that is actually x squared squared. So do 2 times 2 to get 4. So x to the first over x to the fourth. Numerator is definitely less than the denominator. And if that is so, it means that your horizontal asymptote is at 0. Now, the rest of this, we're just going to be plugging in points, right? Since the only points we got were from our x and our y intercept, we're expected to plug in points on the left, in the middle, and on the right-hand side. Now, just to save us a little bit of time with this example, I'm going to go ahead and plug in here. Right, so I would just plug in something to the right of 1, right, make it a 2, right, and plug in points here accordingly. Your graph is going to look something like this. Here in our middle section, this is going to look like a positive cubic function. So it's going to go up like this and then down like that. In the left-hand section, we have a graph in this bottom left corner that's going to kind of mirror this top right side. That's going to look something like that. You can use a graphing calculator to go ahead and just plug this in and verify and help you get the graph as well, right? The problem does want us to use graphing to help us find the following limits. So whether you graph by hand or you're able to graph with a graphing calculator or a site online, right? Gives us this graph right over here. So we can now answer the questions. The limit as x approaches 1 of this function. So we're approaching a 1. Which means, again, it doesn't have a plus or minus here. We're approaching 1, so we're looking at it from both directions, coming from the left side, coming from the right side. The closer and closer that we get to this line, again, we're approaching that line, and it looks like the more we approach the line, our graph is going to just go up, 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 and it's really just going to forever hug that asymptote. This graph is just going to keep going on and on and on from the left and from the right side, and it's never going to stop going. So that means the limit here is going to be a positive infinity since it is shooting upwards forever. The limit as x approaches -1. All right, so we're looking at -1 now from both directions. And if we're looking at -1, the closer and closer we get to this graph, right, we're following the lines of our graph as we get to this barrier here. So as we follow our graph and get closer and closer, notice that our graph is going to shoot downwards. And it's going to keep hugging that line, and it's going to go, 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 and it's never going to stop. And since it's going in the negative direction without stopping, the limit as x approaches -1 of this function would be a negative infinity. So let's talk about this example where g of x is equal to the following, and we're going to find the limit of these 3 things here. So we're going to find the limit as x approaches 1 of this function, as x approaches 3 from the left-hand side, and as x approaches 3. Now, if we're going to find the limit of this, we are going to use graphs to help us find the limit of this function. So that means that we need to get an idea of what this looks like. Now, if you are able to use a graphing calculator, if you have one handy, you can go ahead and plug this in, maybe find a graphing website, plug this into it. If you are a student and you are not allowed to use graphing calculators, it would be in your benefit to learn how to graph this by hand. So if we are talking about how to graph this by hand, so x and y intercepts is what I would start with first. You're going to get your x-intercepts by taking your numerator, setting it equal to 0, and solving. So if I do that, that gives us x minus 2 is equal to 0. Add 2 on each side, and we do have an x-intercept here at a 2. In order to find your y-intercepts, you plug in 0 into the function. So plug in 0 for x. So in the numerator, we would get 0 minus a 2. So that would just be a -2 in the numerator. Right, if we plug in 0 here, that leaves us with negative 1 squared. Negative 1 times negative 1 is a 1. And over here, again, we're plugging a 0, so that gives us a negative 3 there. That really just makes this negative 2 over negative 3, which is a positive 2/3. So that is our y-intercept, a positive 2/3 right over there. The next thing I would find are your asymptotes. Your vertical asymptotes you get by taking your numerator, setting them, taking your denominator. Right, your vertical asymptotes come from taking your denominator, setting it equal to 0, and solving. Now, our denominator is in factored form, which actually works out great for us. Because if it's in factored form, we could use the zero factor property, which says split the factors up, set them each equal to 0, and solve. So I'm just going to add 3 on each side over here, and I get that x is equal to a 3. Right, for this one here, get rid of that square by taking the square root of each side so that we can drop down that x minus 1, and it equals to 0. Add 1 on each side, and x is equal to a 1. This tells me that I have vertical asymptotes at a 1. I also have vertical asymptote at a positive 3. Horizontal asymptotes come from comparing the degree of your numerator to the degree of your denominator. So in our numerator, the degree of our numerator is a 1. If we were to multiply everything out in the denominator, we have an x squared times an x to the first. X squared times x to the first is x cubed. So we have an x to the first in the numerator, x cubed in the denominator. That does mean the degree of the numerator is less than the degree of the denominator. This tells us that the horizontal asymptote is at y is equal to 0. Now, the rest of the graph we can fill in by plugging in points. So on the left-hand side in this section, if you know a little bit about rational functions and the way that those graphs look, given this one point shooting upward, our graph is going to want to hug that asymptote and follow that line. Same thing here on the left. Once you go past this point, it is going to curve here, and it's going to follow that horizontal asymptote. In our middle section, just to help us out a little bit over here, it is going to look like a negative cubic function. It's going to shoot off this direction on the left, this direction on the right-hand side. You can plug in points on either side of it to verify, or again, use a graphing utility. On the right-hand side, we do have a point over here in this space, which is going to mirror this space over here on the left. So it's going to come down just like that, again, following our asymptotes. So now that we have an idea of what this graph looks like, we can answer the following questions. The limit of g of x as x approaches 1. Here is 1, which means as we get closer to this line, again, following our graph, right, moving from right to left, left to right here from both directions, we're going to get closer and closer to that line, following our graph as we get closer and closer. And the closer and closer we get to that line, we see that on each side, it is shooting upwards and it's never going to stop. That means the limit as x approaches 1 is going to be a positive infinity. The limit as x approaches 3 from the negative side. So this is our positive 3. We are coming from the left-hand side. So only from the left-hand side as we get close to this barrier here. Following the left, the closer we get to that line, it's going to shoot down, 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 and it is going to go off to negative infinity for that one. Our last one, limit as x approaches 3. So notice it doesn't have a plus or minus. So we are looking at 3 from both directions. And if we are looking at 3 from both directions, notice on the left, we just answered this, it shoots down to negative infinity. But on the right side, the closer it gets to this line, it's shooting upwards. And because we're going down on one side, up on one side, it's a disconnect. They're not going the same direction. If they're not going the same direction, we say that the limit does not exist for that one.